everyone, this is Mrs. Burt, and I'm going to go through the I do's and we do's from the 5.3 guided notes mole map. So we have our first I do, and I'm going to zoom in a little bit. That asks how many grams there are in 2.00 liters of a 0.456 molar HCl or hydrochloric acid solution. It gives us the molar mass of hydrochloric acid, which is 36.46. So we want to know grams, but we're given liters. So we're starting with liters of the solution. And so if we look over here, that means that we're starting here. So the only direction we can go is this way. And we want to get to grams. So that's mass, which is up here. So this is where we're going to want to go. So following, we would go liters to moles. Okay. And then from moles, we can go to mass or grams. So that tells us there is 2 steps. So this means that we're either going to have 2 conversion factors in one train track, or we can do them separately. I'm going to first show it separately, and then I'll show you how we can do it in one single step. So in our first one, we need to say how liters and moles are equal, and that is actually from our molarity. In the notes, molarity, the big capital M, is the number of moles of solute, in this case that is HCl, in 1 liter of solution. Okay. So we can say that from our molarity, that our conversion factor, number of moles, is 0.456 moles. So 0.456 moles of HCl in 1 liter of the solution. So there's our first conversion factor. Our second one, how moles and grams are equal, well, that's molar mass, right? So for our second one, it's the number of grams, which is 36.46 grams of HCl, is equal to 1 mole of HCl. So we have our 2 conversion factors. So we know how to get between these 2 units going for the steps. So we're going to start with our given, which was 2 liters, so 2.00 liters, and we're going to do our first one. Okay, and we're going to go to moles. So our end answer is going to be moles of HCl. Just like before, we're going to trade them back, do our little disco, and then the liters comes to the bottom so that the liters cancel. Now we're going to fill in here with our conversion factor above. So our conversion factor says 0.456 moles is 1 liter. That's what molarity means. Okay, so then when we multiply, we would multiply the top and divide by the bottom. That causes the liters of hydrochloric acid to cancel. Those units go away and we're left with just moles. And now we're going to do 2 times 0.456 to get our moles of HCl, which is 0.912. Okay, so we have our first step done. Now we're ready to do our second step. So we're going to take our new given. So we're now here. We've changed it into moles. Now we're going to change it into grams. So our new given, do another train track. And our new that we're going to find, our next step, is grams of HCl. Switch them back, so grams on top, and then moles on the bottom. And the grams to mole ratio or conversion factors are molar mass. So 1 mole is 36.46 grams. Now multiplying the top and dividing the bottom. Dividing by the bottom causes the moles to cancel, so we're left with just grams, so our units work out. And then we take the 0.912 times the molar mass, and you should get 33.3, because of 3 sig figs, grams of HCl. Now you can do this in one single step, where you start with what you're given and set up your first conversion. And then you now know you're at moles because the liters have canceled out. So now you want to go to grams, and the moles now come down diagonally to cancel, and you fill in your molar mass. Either one of these methods is acceptable. They both work out. The units still totally cancel out. And when we multiply, we see we still multiply across the top, and dividing by the bottom is only dividing by 1, and you end up with the same exact answer. Okay, so you can do it as 1, 2 separate conversions, or 1 altogether. Either one works. You just need to figure out which one makes your brain function right and go with it. Okay, moving forward to our next we do. So I'm going to erase this so we can use our map again. So we want to know how many atoms of chlorine there are in 5.12 liters of SCl2 gas, or sulfur dichloride gas, at STP. So we are given liters of a gas. So we are actually starting here. And we want to know how many atoms there are in a compound, right? So that's more than just particles, that's atoms, because the atom is part of the particle or the molecule. Okay, so in this case, we're talking about the molecule. So we're going to go from liters of a gas to atoms of a gas. That will give us 1, 2, 3 steps. So 1, 2, 3 steps. Okay, so I'm going to do it first individually, and then I'll do them all. I'll run through it again all together. So our first step has us going from liters of the gas to moles of the gas, and that's our first step. Our second step takes the moles to molecules of the gas, and then in our roadmap, our molecules then are going to be changed in our third step. So there's the second, here's our third. The molecules are then going to be changed into atoms of chlorine. Okay, so I'm going to do it off to the side. Our first conversion factor is going to look at how liters of the gas are equal to moles of the gas at STP. And if we look back at the conversion on the side, it actually tells us that 1 mole of gas at STP has a volume of 22.4 liters. That is a known value given to us through Avogadro's research. Then our second one, we're going to relate how moles of the gas is equal to molecules of the gas. Sorry, I'm running into the mole map. Well, looking back, that is here, and we know that 1 mole has 6.02 times 10 to the 23rd molecules. And our third conversion factor is going to relate the moles of the gas, or not moles, molecules of the gas, excuse me, to atoms of chlorine. Okay, and so it actually gives us a hint that in the one larger particle or molecule of SCl2, we have 2 atoms of chlorine. So we have our 1, 2, and 3rd conversion, so our 3 conversion factors. So now we're ready to start working on that. So in our first step, we start with liters, which it tells us that we have 5.12 liters of SCl2 or sulfur dichloride gas. And in our first conversion, we're going to change that into moles. Okay. And so doing that, we will see, and I'm going to try and write this a little smaller. We're going to change it into moles. I don't know if that's any smaller, but we'll work with it. 22.4 liters is 1 mole of gas at STP. That's defined that way, and that was our first conversion factor. So we will multiply across the top, which is multiplying by 1, and then dividing by the bottom, you end up with 0.229. Now this one's rounded. I'm going to leave it unrounded in my calculator, but that value is rounded right now. And the liters cancel out. So then we're ready for our second one, because we've gotten to moles. We're ready for our second conversion. And so we'll put moles on the bottom. And we're going to change it into molecules. And now our second conversion factor says 1 mole is 6.02 times 10 to the 23rd molecules. Okay. And so from here, we're going to do the same thing we've been doing. Multiply the top and divide the bottom. Moles cancel out, and you are left with 1.38 times 10 to the 23rd power molecules of SCl2. Now I've run out of room, so I'm going to come to the other side. And I am going to continue with that number. I'm leaving it unrounded in my calculator so I can reuse it. This prevents it from accumulating a lot of rounding errors and making super big differences in my value from the beginning to the end. So now we have our molecules of sulfur dichloride. Now we're ready for the third conversion. And in the third conversion, we see that molecules needs to come on the bottom so that it cancels out. And what we want in the end is atoms of chlorine. And so we use our conversion factor where 1 molecule has 2 atoms. And now we're ready to cancel and finish solving this out. So multiplying the top and dividing the bottom, we see that molecules cancel out, and multiplying that by 2, you see that you get the answer of 2.75 times 10 to the 23rd atoms of chlorine. So you can do this all in one step, where you don't have to write as much like we showed earlier, right? And then it takes me forever to erase it all, but that's okay. We'll make it happen. Well, it may not come up this time. There we go. Okay, so we can start with where we're going, and if we did our roadmap, it would actually tell us exactly what goes on the top, right? So our roadmap tells us the path we're going to take. So first we're going to go from liters to moles. And then we go to molecules. And then we will go to atoms of chlorine. All right, that gives us the full path. If you actually check the 3 separate steps, you will see that it all matches just down that way. So we can take this now and drag the previous conversion factor diagonal so that it cancels. Drag that diagonal, and you will see that this mirrors the conversion factor you would use from 1, 2, and 3. So it is very important to write the roadmap and to determine your conversion factors at each step of that roadmap. Okay, you are perfectly okay to write the mole map on the back of your periodic table. I'm going to try and print you guys one, but we'll see how fast I can get that done. Okay, but you are perfectly okay to also write it on the back of your periodic table. So dragging things diagonally and then using our conversion factors to fill in the spots, we end up, that's a 10, really bad 10. Easy. So 1 molecules, 2 atoms, and we notice that the math is going to be the same. You'll multiply across the top and divide by the bottom to get the same exact answer. Okay? So either one works. You will see me doing this method the most because it saves space. Okay? However, on tests or quizzes or worksheets, I try and give you ample amounts of space if you want to do it in more than one single line. Okay? And if it isn't quite enough for you, feel free to use a separate sheet of paper. So our last we are going to look and determine the mass of this many particles of water, and it's nice enough to give us the molar mass of water. So if we go back to our mole map up here, we are, and I'm going to erase some of these because they're in the way. We are starting at particles of water. So we're starting here, particles, and we want to get to the mass up here. So we see we are going to go from particles to moles, and then from moles to mass. So we have 2 steps. Now in this example, I am not going to break it down into 2 separate conversion tracks. I'm going to do it in one, but I'm going to walk you through it. So we're going to write it out. We have particles of water given to us, and we're first from our mole map going to change it into moles. We can't go straight to grams because there's no conversion factor that relates particles and grams directly that you can always use. So mole of water, and then once we hit moles, we take a turn and head north, I guess, and we end up going to grams of water. And so that gives us 1, 2 conversion factors. So we're going to have to figure out what those 2 are. So our first one relates particles to moles, and it actually gives us to it in the mole conversion map. So 6.02 times 10 to the 23rd particles is 1 mole. Okay, and then our second one, so we've gotten our first one. Our second one, moles, so we want to relate moles of water to grams of water. And they give that to us in the equation, right? Grams and moles. So that's our molar mass. So 1 mole has a mass of 18.02 grams for water. So we have our 2 conversions, we have our roadmap, so now we can build our train track. So setting up our train track, notice when I do my roadmap and I draw my lines directly under the arrows, it tells me what I put where. I'm going to abbreviate particles just because it's a really long word. And then I put moles and bring it in, and then grams. Okay, so focusing on my first conversion track, I'm going to fill in what I'm given, which is 3.23 times 10 to the 24th particles. And then particles I'm going to drag diagonally so it cancels. And from our first conversion, because that's how we're going to change it, our first conversion relates particles and moles, I'm going to fill in the matching numbers. So it says 1 mole is 6.02 times 10 to the 23rd particles. Okay, so my particles have canceled, so I go to my next. I'm now at the mole step. I'm going to drag moles diagonally so they end up canceling. And now this is my third conversion ratio. Not third, second conversion ratio, sorry. And so the second one says 1 mole is 18.02 grams. So again, we're going to multiply by what's on top and divide by what's on bottom both times. So start with the first one. So we'll do 3.23 times 10 to the 24th divided by 6.02 times 10 to the 23rd. Putting that into your calculator, you should get 5.365 and some odd, so 5.37 technically. Okay, and that's simplified. There's no times 10 because technically dividing by 10 to the 23rd and 10 to the 24th, they nearly cancel each other out, so it shouldn't be a very big number. The units also cancel out, and so you're left with moles. So now, and then make sure you hit the equal sign after putting it into the calculator so you have that number. So now you can multiply, so let's do that, multiply by 18.02. Oh, in my notes, I think it's wrong. Oh, I flipped the numbers. I'm sorry, guys. So in the lecture slides, I flipped the numbers. But the truest answer is 96.7 grams of water. Right? 3 sig figs because there's 3 sig figs here. So when we multiply here and then we would divide by the bottom, the moles cancel out, and that leaves us with just grams. Okay, and so that's the unit we carry forward, and through our math we should get this. After every step, when you hit that function, like the first one we divided, we hit the equal sign to get a number. Then we hit the multiply sign to multiply by 18.02, put that in, and hit the equal sign and get a number. So after, like up here in this other one, we would divide and then hit the equal sign, and then from that number we would hit the multiply and get this number in there and hit the equal sign, okay, and then multiply again. So after each step, make sure you're hitting the equal sign in your calculator, because otherwise your calculator might read it backwards from what you intend. Okay, so this concludes the I do's and we do's from the 5.3 guided notes. Thank you guys.